Last video, we talked about the ideas of simple and compound interest. And so with the simple and compound interest formulas, you're looking at situations where you put money in an investment account and just leave it until the end, and then you figure out how much you have at the end. Or you borrow money and just don't make any payments and leave it until the end and then see what you owe. Okay? And so both of these situations, while they can happen, there are times where these are used. So, for example, like a student loan, you've borrowed money for a student loan right now, and you're just paying interest on it. That interest is just accumulating until you graduate. Okay? But once you graduate, you're going to start making monthly payments on that student loan. I hope you knew that already. If you didn't, surprise. They're going to expect you to pay money back on it every month. And so you will need more complicated formulas for this. Okay? And so these formulas are based on what's called an annuity. So we're going to start off with just the simple annuity formula, which is where we're making deposits into an investment account each month. And then we'll talk about a payout annuity, which is where we withdraw, and then we talk about loans. Okay? So let's start off with an annuity. So this is where you're saving a particular amount each month. So in an annuity, we save the same amount each unit of time. Okay? So your parents, for example, may have set aside a certain amount each year or each month for you to go to college. You might save up money for a car or something like that. This is an example of an annuity. So say, for example, you save $50 each month in an account that pays 7% interest for 5 years. Okay? And so if you just think about this for a second, you might be tempted to say, okay, $50 each month for 5 years. So $50 times 12, that's $600 a year, times 5 years, that's $3,000 over the 5 years. Take that $3,000 and add 7% to it, and you're done. But it's not that simple, okay? Because if you think about it, you're not earning 7% interest on that $3,000 the entire time, right? So when you start off your first month, you've just got $50 in there, right? And so you're only getting that 7% interest on that $50. After another month, you add another 50, and you've got the original 50 plus that 7% interest on 50 plus another 50. Okay, so this builds up in somewhat of a complicated way. You can see that it's a lot more complicated than just simply taking how much did you put in and adding 7% to it. Okay, so we have a formula for this. So what's called the annuity formula. And you'll notice it looks kind of like our compound interest formula, but more complicated. So the annuity formula has the amount that you're going to have at the end of the amount of time is going to be your deposit, whether that's monthly or annual or whatever. So however much you deposit each time, times 1 plus the rate over the number of times you compound to the number of times you compound times the amount of time minus 1 divided by the rate over the number of times you compound. Okay, so this is the annuity formula. Notice here that the 1 plus r over k is raised to the kt power, and then you subtract 1. So you can't just say this 1 plus and this minus 1 cancel each other out, because this one is getting raised to the power. Okay, so you have to be super careful entering something like this into your calculator. You should definitely practice it before the exam, because it is a little bit trickier than some of the simpler formulas. Okay, so if we look at our example here, let's put all of our different numbers into this formula. So D is the amount we deposit each time. So that's 50. The rate is 7%. So R is going to be 0.07. K is the number of times that we're compounding, the number of times each year that we're making deposits. So that's 12 here because you're depositing money each month. Okay? So 12 for K, 12 for K, 12 for K. And then finally, the time, just like we did before, 5 years. So 12 times 5. And so we get 50 times 1 plus 0.07 over 12 to the 12 times 5 minus 1 over 0.07 divided by 12. Okay? And so again, like I said, putting this into the calculator can be really challenging. Make sure you use lots of parentheses. So we've got parenthesis 50 times, both of these parentheses, 1 plus 0.07 divided by 12 raised to the 12 times 5 power, put parentheses around the power, minus 1 divided by 0.07 divided by 12. And if you put this into your calculator properly, you should get 3,579.65. Okay? So just like with exponential growth, we need to be really careful here that we go through all of the steps and that we don't round too much, right? So you could do 0.07 divided by 12 and round that. But if you round it too much, so 0.07 divided by 12, just that by itself, is 0.00583 repeating. So this is 0.0058333, and so on and so forth. And if you just, say you rounded this to like just 0.0058, and use that here and here, you would get, let's see, 50, parentheses, 50 times 1 plus 0.0058 to the, oops, I need one more parenthesis. One plus 0.0058 to the 12 times 5 minus 1 divided by 0.0058. So with that rounding, say you round it off of these other numbers, you would get 3575, 94. Okay, that's if you round to 4 decimal places. That's keeping a lot, and your answer is still off by $5. Okay? So when we take the quizzes and the exams, I will give you some leeway here because it's very easy to make rounding mistakes with these problems, but you still need to be super, super careful. If you can, you should put it all into your calculator at once, and that's going to be best. Okay? So let's look at another problem like this, another annuity problem where we're making the same deposit every, we'll do year this time, but let's look at a kind of a different type of problem. So say you want to save, say, $20,000 for college by depositing the same amount each month into an account paying 8% interest say 8 years. Okay, so say you're saving money for your kids' education. You've got 8 years to save $20,000, and you want to save the same amount each month. How much do you need to put into the account each month? And so this is a different way of using the formula, right? Because here now we have to ask ourselves, what is the D, right? So we know that we want to have $20,000 at the end, but what we don't know is how much we need to deposit each time, right? That D variable. And so we've got everything else. So 1 plus, we've got 8%. Again, this is monthly, so divided by 12. So to the 12 times 8 years, minus 1, all divided by 0.08 over 12. Okay? And so now we've got to solve for D. And this seems tricky, but it's actually not that bad. So what we can do, if we want to get D by itself, we can move this 0.08 over 12. We can multiply both sides by it. So we get 20,000 times 0.08 over 12 equals D times 1 plus 0.08 over 12 to the 12 times 8 minus 1. And then if we want to get D just by itself, we can divide by this entire piece on both sides, okay? And so then, I'm going to write it up here because I'm out of space. We get D equals this piece, 20,000 times 0.08 over 12, all divided by this whole piece, 1 plus 0.08 over 12 to the 12 times 8 minus 1. Okay? And you don't have to do it this way, right? So you could figure out what 20,000 times 0.08 over 12 is as a number, right? As a single number. You could figure out what this is as a single number and then divide by this to get D. That's fine. It's a little bit better to do it this way because you don't get any rounding problems. I can plug all of this directly into my calculator. I can say I've got 20,000 times 0.08 over 12 divided by 1 plus 0.08 over 12 raised to the 12 times 8 power minus 1 and get 149.40 as my final answer. You need to deposit $149.40 each month for 8 years into this account, and you'll have $20,000 at the end. Okay? So if you think about kind of just practically what that is, just a kind of a quick way to check and see if this makes sense. Over 8 years, you deposit 8 times 12 times 149.40. So over those 8 years, you've put 8 times 12 times 149.40, so $14,342.40 in the bank, and then the rest to get to $20,000 is interest that you've earned. Okay, so that's pretty reasonable, right? You can think about adding 8% onto this to get to 20,000. Again, isn't exactly right, but that's the idea, and that's pretty reasonable. You put $14,000 in the bank, you ended up with $20,000. It's not that much of a stretch. Okay, so what you've done is, since you know that you've got $20,000 at the end, you've earned 20,000 minus 14,342.40 in interest over the 8 years. Okay? So that's another way to look at it. Okay? So that's solving problems with annuities. There's another video that goes through some more. And then, of course, there's also the notes.